Thanks again, everyone, for joining us today. I really appreciate you taking the time out of your day to spend this session with us. I know that there's a lot of demands on your time, and we do really appreciate it. And hopefully, we can, you know, help through some, deep dive on edge topics. So specifically, what we'll be covering today is post production. So if you go back into the Reactor YouTube, you'll see that we did a session back in November on deploying your models to the edge. And what we're going to talk about today is beyond that. What do you do once you've got those models into production, and making sure that they perform the way they're supposed to. And so we'll be covering that element of manage, observe, monitor. And then if you do need to update those models, how do you go about that without disrupting the production and that continuity that you want to achieve from the models in deployment? And so we'll be talking through some use cases and we'll go through the challenges as well that most people face in the sort of data science or ML engineer space when dealing with models at the edge, and especially if they are in a situation where you might have sporadic or maybe not persistent connections with those edge devices. But the bulk of the time that we'll spend today will be on the demo and actually showing the practicality of this. And this is where my colleague Steve will come in and deep dive into the code and the technical best practices as we see it from managing those edge deployments. We'll also have an opportunity at the end for Q&A, but we do want to keep this interactive. So if you do have questions, please, fire them into the chat queue. We have our colleague manning the chat queue, and he can help answer questions, and we'll deal with some of them at the end as well, so we can, make sure that this is interactive and informative as well. So just a quick introduction. My name's Martin Bold. I'm the Senior Manager of the DevRel community at Wallaroo.ai. I've been very fortunate to be in the industry for, over, come up for 3 decades now. And the bulk of that time was spent actually at Microsoft with probably one of the most rewarding times of my career, working with folks like yourselves in hands-on labs, workshops, and doing those videos and those, POCs, etc. And so great to, again, be back and in front of that community again here. I'm just going to hand it over to my colleague, Steve, who will introduce himself.
Thanks, Martin. Thanks, everyone. My name is Steve Notley. I lead our field engineering team here at Wallaroo AI. And so my background, I've been in the AI space. This number is a little bit old, coming up on 10 years now. And so really started in academia and doing research as part of my graduate degree on the AI space. Did a lot of really interesting work there. But one thing that I noticed was that there was so much interesting work coming out of academia, so many new architectures, new applications, and yet by comparison, the amount of those that actually made it into real products that were reshaping industry or reshaping consumer life was really low by comparison. So I really got into industry to explore how to accelerate that link of those exciting revelations, those new technologies really starting to make an impact on real world problems. And so I've been very close to applied AI for my whole career, and I've worked in industries such as financial services, energy, manufacturing, and healthcare. And so one thing that I noticed across all of those industries was that making that leap to production and that deployment piece was always a bottleneck, and that was one of the key pieces that I was, that was causing that lag of that cycle that I was seeing when I was in academia. And so Wallaroo AI is a company dedicated to helping solve that problem exactly, and that's what brought me here. So thank you all for having me.
Awesome. Thank you, Steve. So as we talked about, we have covered the deploying edge models into production, and there's a number of different use cases. There's probably a lot more that we can fit on one slide, but just to give you an idea of where edge AI is being used, especially since in the last 12 months or so, where it's really taken a leap forward, especially with Gen AI, also with the capabilities of devices and the power of those devices that can be put in those edge scenarios as well. You've probably experienced some of the retail, cashierless checkout, and also retail are really using AI to manage that inventory. We've seen supply chain issues recently in the last couple of years and post COVID, and that inventory management is super important for the retail industry, not just for supply chain but also in the store and monitoring product and does product go off for the fresh produce, etc. We've also seen manufacturing. Manufacturing have been using edge and sensors for years, since before it was even called IoT. And with the advent of edge AI, there's a new possibility for manufacturing to take advantage of this technology to help produce much more accurate products through Q&A analysis and also predicting maintenance, so that they can make sure they can optimize their staff for those alerts and operations, and keeping those costs down as well. We've also seen in health and life sciences where through COVID, that really took a leap forward in those models being able to manufacture and help build those vaccines that that we've all taken advantage of, as well as the sort of diagnosing illnesses. There was a recent article in the BBC that folks had been diagnosed with cancer that some specialists had missed, and so you were talking about life-saving capabilities here with edge AI and the ability to recognize certain cell structures and so on in that space. And also within energy, whether it be fossil fuels through to green energy, a lot of those instances are very remote, whether there be pipelines, wind farms, as solar arrays, etc. And they want to make sure that do we just send people out to these remote locations to make sure that things are working. Sometimes those remote locations don't have the persistent connectivity that we experience in a more sort of urban setting. And so for energy, they're using it to help with that predictive maintenance element, monitoring, supply as well through, wells, through pipelines, and through, the energy that flow rates are generated by wind farms. And these themselves, generate a lot of challenges for folks that want to take advantage of this. You're not just deploying one model out to one endpoint. You're deploying it to tens, hundreds, and thousands in a lot of cases. This can also rack up a lot of cost as well, especially when you're looking at things like bandwidth. If you're capturing computer vision at the edge and you're sending those images up to a central cloud to be processed and analyzed, that bandwidth cost, that delay in that sending that information up can lead to lack of performance and so on. And I was involved in a project where we were monitoring grocery food and coolers in grocery stores. And what we found was that we were using an edge device. We were using a SIM card to send that computer vision data back up to Azure, and just the cost alone of sending those images through mobile network ended up being almost cost prohibitive to the project. And so the ability to process that data right on the edge with the power of those devices that we have now is super important, and it's a great opportunity to take advantage of that. But they also need the skill and expertise in house to do that. And folks are struggling to find the right skills and expertise that they have. We've also seen tech layoffs, and people are adjusting their career paths and they're learning new skills. And so being able to give the self-service capability to data scientists and MLEs that know these models and know how to work with them, so that they can help manage those models, monitor, look for discrepancies and performance issues, and also give them the self-serve capability to update those models in production without having to go to the DevOps or the IT ops folks to make a request to them. Those folks are super busy, and it then goes into a queue, and that causes delays in production. And so being able to give that power to the data scientists that work with the models and the MLEs that work with these models to be able to recognize that there is a performance issue and then update that model in line with the production without having to take that environment down and stop production, redo the model, redeploy it. That can all take time. That leads to higher costs and a delay in the sort of return on investment that businesses are looking to take advantage of. And these are just some of the challenges. There are a few others, I'm sure, that folks are coming across. And yeah, if you've been through this, we would love to hear from you, because these are the things that we want to take back from the community and listen to the community and put it back into our product and help make it better for folks like yourselves in the long run. So we've introduced ourselves, we've talked about Edge AI, and okay, well, who are we at Wallaroo.ai? We are a Microsoft startup. We're part of the Microsoft for Startups program. We're part of the Pegasus program as well. We're also funded by the Microsoft M12 group as well. And so what we do is our platform is production AI at scale. And so it helps businesses take those models that you spent a great deal of time and effort and energy on in your pre-production for training those models and getting them to the point where you want to deploy them to production. And so what the Wallaroo platform does is it helps you quickly and easily deploy them into production with a minimal amount of code. And regardless of where you want to deploy to, whether it be on premises, whether it be in the cloud on Azure and Azure ML, or in this case that we'll talk about for edge scenarios, you can quickly do that in an environment that is native and familiar to the folks that are working with that. But we also go beyond that. We have monitoring capabilities that allow you to monitor for data drift. You can look for anomalies within those models. You can also manage deployment of those models and when they run and how they run. And so within Edge, you might have batch processing that you're running. Maybe it's running every Sunday night at midnight, and you can orchestrate that, and that helps you scale so that you're not doing a lot of manual intervention and trying to stop-start inferencing of models. And so we also have the capability, which we'll see in Steve's demo, to look at a model and say, from our monitoring and observability, this model is not performing well. So we can then take that and retrain a better performing model and then deploy it on the fly without taking down that production environment. And that's who we are. We integrate with those technologies that you're already familiar with and plug in and help you scale those models into production, regardless of the architecture or endpoint that you want to deploy it to. I'm going to hand it over to Steve. Steve's going to now take us through that example that we've been talking about for how do we take a deployed production model for an edge example, and then how do we sort of run through that life cycle to make sure that it is performing the way it is, and how do we proactively act if it isn't. Steve.
Absolutely. Thank you so much, Martin. And just to address that last slide before we get into the demo here. So this is kind of what we're going to see today, right? So what we're seeing here, deploying, serving, observing, getting insights, ultimately retraining, updating that model, and then redeploying it. What we're essentially describing here is, a really healthy, robust ML operations lifecycle. And so the reason why we wanted to talk about this today is that ML ops and this kind of healthy life cycle is something that a lot of folks are still figuring out the best way to address, even in the cloud, right? This is something that is still an area where folks are trying to tighten up their production AI. And when you take that and you actually bring it out to the edge, it introduces a whole other host of variables that really, in a lot of ways, is kind of greenfield, right? So we're going to go through today, what each of these steps look like. We're going to address the cloud briefly first, and then we're going to see the additional complications, some of the additional information and possibilities that come in at the edge, and some ways to address that as well. And so the specific example we're going to be looking through is an example around using sensor data, like you would find in a manufacturing setting, in order to predict remaining useful life of a mechanical component based on historical failure data. And so we're going to switch over to our demo now. And so what we can see here is a Jupyter notebook, right? So we're going to pick up where our data scientists would kind of typically leave off, right? They have a model that they've trained, probably using Azure ML, as many of our customers do. And they're, have that model, they've trained it, they've validated it, they're ready to actually go ahead and make that leap into production. Now, as Martin said, we covered in a lot of detail the process of kind of getting to production and a couple of previous entries in this series. So I'll go through that piece. I'll recapture some of that briefly. And then we're going to focus on really what happens, once you're in production and how to think about that kind of continuous life cycle. So I go ahead and start off here. And so I effectively, import a couple of libraries here, make a connection out to my instance of Wallaroo. And then the first thing I'm going to do is actually take my saved model, which we have here in this Onyx file, and I'm going to run one last test on it in a production setting. So first, we're going to put it into production by packaging up and making it available as a cloud-based endpoint as kind of our first test. And so we can go ahead and do that in a couple of lines of code here. And so, it is a good practice to test on every, kind of phase of the production lifecycle. And so this first one around packaging this up, we can go ahead and undertake that packaging. I upload with my model name and kind of tell the Wallaroo service what kind of model this is. In this case, it's an Onyx model. So I say, this is what we're looking at. Go ahead and register it. And then we go ahead and define some sample hardware. Now, this deployment configuration and the hardware associated with it, and keeping in mind things like scaling, is a bigger component of course, cloud-based deployments. But even when our final target is the edge, it's a great idea to start here and try to deploy to a cloud location with similar resources that you would expect to find on your edge device, so that you can examine that performance, examine those results, and make sure that everything looks as you would expect. And so we do that. We essentially define a pretty small deployment configuration, 1 CPU, 1 gig of RAM, that we can go ahead and build and ultimately deploy our model out to. And so at this point, I have a sample production endpoint in the cloud that I have here that I can start to run some sample data through. And so I have a sample set of inputs that I go ahead and run through, and you can see I get my output here that is essentially the number of predicted cycles left to a mechanical failure. And so with that context that this is looking good, these results are what I expect them to be, we can start to turn our attention to our final goal, which is great. I have this model, it predicts these failures. This is going to be useful in optimizing my maintenance routines. But I have all of these assembly lines, right? I have, I'm a global manufacturer. I have all of these assembly lines that I have to think about. They're in different regions. Some of them have different hardware. How do I actually go ahead and get that out to the edge so that I can overcome some of the problems that Martin had alluded to earlier, right? The sheer volume of data coming off of these sensors is a blessing and a curse. I have so much that I can leverage to make informed decisions. But at the same time, if I have all of these locations, they're all generating a ton of data 24/7, then I need to think about, what that looks like from a logistic perspective, and, the costs of potentially streaming that back to the cloud, or even just the hit of latency. There's a lot of reasons to want to bring that computation closer to where all of that data is. In this case, that would be a machine close to our factory floor. And so the process of actually undertaking that leap to the edge is essentially going to entail having some sort of container that you generate in order to ensure reproducibility and consistency across these different hardware environments and potentially different runtime environments, right? So we want to make sure that we can generate a consistent environment across all of these different kind of hardware possibilities. And so you can, of course, do that many ways. You can, have your ML engineering team create that, container. You can test it out. Today, for this example, we're going to be using Wallaru's functionality, which essentially automates that container creation process based on that pre-existing cloud deployment that we just made a moment ago. So what I'm going to do is take that pipeline artifact and publish it. This takes a few minutes to run, so you can see that I pre-executed it here. And what that is effectively going to do is take all of the things that were done at the previous cloud deployment stage. That is going to include that model packaging, that container creation, optimization for my given hardware profile or profiles, and essentially take all of that and make it into a self-sufficient Docker image that I can actually see here sitting in my registry. And that's going to allow me to take that same deployment that runs the same way and take it and distribute it out to all of my edge devices to actually bring that computation local to where that data is being generated. And so that first step of publishing does that, right? It automates that container generation. But the next piece is, great, now that I have that container and I'm going to go ahead and put it in 1 or 10 or 1,000 locations, how do I actually keep track of those deployments? And this is the first area where we see folks, really struggling with that kind of normal ML ops lifecycle, right? This is the place where it first meaningfully deviates from the cloud, because you have all of these things that you go ahead and distribute out. But what we find is that there's not a lot of action currently towards actually managing those once they're out on the edge, right? I have all these Docker containers. As some things change or I notice defects, maybe I'm replacing them in a one-off way, and I end up with, all of these locations. No one knows what versions they're on. Maybe they haven't been analyzed in a really long time. And I sort of have this tendency to lose track of these things once they hit that production, right? And so, one answer that we often see when we say, hey, how are you monitoring these things or managing them, out on the edge? A lot of times people are kind of saying, well, we check in on them, but we don't have as tight of that management loop as we would like. And so there's a bunch of ways to solve this, right? There's process solves, there's software-based solves. Wallaru has some functionality that helps with both that we're going to leverage today. And one of them is actually registering specific edge devices. And we'll see all of the functionality that comes with doing this a little bit later on. Right, so I'm going to go ahead and add an edge. I give it a name, and the output of this I can see is essentially all of the information about what was packaged, the artifacts that are included, and then importantly, it's just going to give me a Docker run that I can go ahead and actually just copy in order to set this up on my edge device. And so if I go ahead and copy this over, I can flip over to my sample edge device. You can imagine that I've SSH'd into one of these machines sitting in the back of one of these locations. I can go ahead and simply paste that, hit enter, and this is going to actually kick this Docker container off and have it running. And so without having to really do any of this myself, I now have this running locally close to where my data is generated at the edge. And on the right-hand side here, you can see I'm simply going to curl this endpoint with some sample sensor data so that I can see those results actually being generated. Of course, in real life, this would be some sort of continuous running application that's going to make use of this, such as something that is scheduling maintenance or a system that is kind of handling how to flag or alert people when maintenance is required and essentially monitor that I'm within my acceptable thresholds here. And so jumping back over to Wallaru, what that has essentially done by using this is, of course, the obvious thing that we just showed of actually running this at the edge. But the more nuanced thing here is that by actually registering this specific device, this key is going to actually be embedded into this Docker run. And you can see that here in the form of this edge bundle. And this contains a lot of information, some of which is security related, ensuring that you're not having bad actors pretending to be devices on your, edge deployment. But it also allows for a configurable amount of information to be sent back to essentially your operations center, your centralized place where you can view all of these things. So as we'll see in a minute, that data actually comes back and I can see how my different edge devices are performing over time. And so you can see here, just to show another one, I spin up another edge device and I have the same thing. You'll notice that actually the engine and pipeline artifacts are exactly the same, but because it's a new device, this has a slightly different token here that I'll use to kind of authenticate that edge device and manage that communication back to my centralized deployment operations center. And from there, we move on to monitoring, right? So I just mentioned that effectively these devices will transmit some data back in a configurable way. And so in this case, I've configured it to send, instead of all the sensor data, just those outputs back around the remaining useful life, right? And so what that is going to do is essentially globally reconstruct a log in this central location that I can then parse for information and analyze that behavior. And so this is another area where, again, there is a lot of challenges that we see in Edge that go above and beyond the kind of equivalent challenges at this point in kind of a normal cloud production setting. And so one of those things is the fact that we, of course, by design here, have multiple locations. So I'm used to monitoring for things like model drift that could say, great, I trained this model, but my input space is changing over time. So globally, I have this phenomenon that's changing and maybe my model isn't performing as well. That, of course, is still an option at the edge. But what I also see is device or region-specific phenomena. It's possible that things have changed in some locations and not others, causing a disparity in performance. These are also often associated with physical hardware, right? So in this case, we have physical sensor data that we're analyzing. In a computer vision example, you may have sample camera data that you're analyzing, specific frames or videos. And those devices are also prone to defects, right? So that's another effect that, depending on the application, I may or may not have seen in the cloud. So I have the normal data and model drift. I have things introduced by region or location specific drift. And I also have that variable of the physical hardware and the things that can happen there. And so to highlight that, Wallaroo's built-in monitoring system is what we call assays. And essentially, assays are a way for you to configure an automatic monitor on top of any input or output variable of a pipeline based on what is available. And that is supported fully for cloud deployments, edge deployments, or even hybrid deployments that have both cloud and edge endpoints. And what it's going to happen is I effectively define a baseline that says, great, here is kind of how I expect this data to look for either my input or my outputs. And if that essentially drifts such that the data from a given period, every hour, every day, every week, significantly differs from that baseline, I will get alerted and I'll be able to actually dig into that information. And so what we do here is essentially define an assay that we have here to say, great, we're going to actually apply this to this pipeline. And in this case, for the purposes of this example, we're going to look at a very tight window, actually analyze this every minute, and we're going to look at all of our locations in this case. And so I can see here some interesting phenomena, right? So over a couple of minutes, as I'm thinking through, okay, sensor data is coming in, it's predicting this remaining useful life, I see a jump. And this is a jump in the essentially difference between the data coming in and that baseline. So I can see that there's some departure that is causing a difference even just over these few minutes. And that's something that should stand out to me as something that's quite odd, right? Because remaining useful life, you would expect steady curves that maybe accelerate a little bit towards the end of life, but you wouldn't expect a big jump from 1 minute to the next like this typically. So what do I do now? As we just talked about, because this is something that's out at the edge, I need to dig a little bit deeper, right? Is this global? Is this a location-specific thing? What does this actually look like? So Wallaroo is actually going to let me take this assay and parse these results apart so that I can see how the different devices that we have here look from each other. And so I can see here for one of my edge devices, I pull the same data, same window, and I can see this being very steady, right? There's a little bit of fluctuation up and down, but mostly it looks a lot like a straight line. And that's kind of what we would expect to see, very little variation over a couple of minutes. Now, if I look at my second device, I can see here the same pattern that I saw globally, but I can see it much more sharply reflected here, right? And so that's going to tell me, okay, I've started to see some of the constituent devices that actually are contributing to this alert. And you can see here, these red dots mean I actually would have gotten alerted that this specific device and assay triggered here. And that's going to allow me to kind of isolate the culprit and then decide, what am I going to actually do about this? And so the next step, I would dig more into the data here and, potentially take other steps to actually figure out why this occurred, whether it is some sort of difference in the input space itself. Maybe it's someone swapped out a sensor for a newer version for which there is a different data type or different range, different sensitivity, or perhaps it's a fault in the sensor itself. It could be, a number of those things. In this case, what we actually did to simulate a sharp departure like this was actually just have a sensor fail, right? So we simulated, what if one sensor just failed, stopped producing any data at all? How would my model react? And we actually see those carry through to the output results here, being a sharp departure that we wouldn't expect. Now, so we've gone through, okay, how do I keep an eye on these edge deployments? How do I actually see, what they're looking like, how they're performing out at the edge, and keeping abreast of any problems as they crop up? Now, what do I do when I want to actually, fast forward a little bit in time? It's been 6 months later. I've scaled this up. I now have it at, 20, 50, 100 sites that I have globally. How do I actually then, switch over to the latest and greatest model that my data scientists have been working on, right? We've made some advancements. We're pretty sure we can dial this in to have a more accurate forecast around this remaining useful life so that we can further optimize that maintenance schedule. How do I actually go ahead and take this and actually get it out to all of my physical locations? So again, there's a number of ways to do this. It's going to involve some of the same steps that we had originally. In this case, taking that new model and still registering it, still deploying it out to test it. However, one thing that Wallaroo is going to let me do is actually make this a little bit easier by having a lineage of what these models are, how they're published, and what that actually looks like. And so you can see here that these steps look the same, right? I go ahead and actually, upload this and deploy it to the cloud on my sample hardware. I run any testing that I need to validate that those results are as I would expect. And from there, I go ahead and publish. But you'll notice that this is a little bit different this time, that I have an additional argument with a reference to my previous publish. Right. So I'm going ahead and saying, hey, I actually want this to be an inline replacement of this artifact. I want this to be the version that is meant to be the replacement for this one. And so what that's going to do is then as I go ahead and publish that and as it completes, not only do I get all of the usual information that includes these updated artifacts, but I'm actually going to get a replacement section that automatically generates refresh tokens to all of my edge devices. So that from here, all I actually have to do to update these is to actually copy these Docker run commands again, go back over to my edge device and simply swap that Docker container for the other one. And so everything else will remain the same. My logs will remain continuous. My assays that I set up to monitor that drift will remain in place. The endpoint for the model itself will remain in place. Nothing about my end applications actually have to change. I simply just bring a Docker container down and bring another one back up. And so that is something that can help minimize this downtime as you're thinking about managing this fleet of models that are out there and dealing with the process of actually figuring out how they're performing, keeping abreast of the latest changes, and then actually going ahead and updating them as needed. And so we think this is an area that's really important to ensure that we have really good high fidelity predictions, not just in the cloud, but in the ever-growing space of edge deployments there. And with that, that's what I had planned for the demo today, and I can turn it back over to Martin.
Awesome. Thanks, Steve. Great job. I really appreciate it. And so, yeah, like Steve's shown us how, you can make sure that you have that sort of continuous monitoring, that tight feedback loop as a best practice to, make sure that when these models are deployed, regardless of the environment that they're in, that you can really see, okay, are we getting that drift before it becomes an issue for the business. And the example I gave previous earlier in the session today, one of those coolers are when we ran them in the lab, with these cameras checking the product, and it was all great, and got to the site, and we just weren't getting the performance that we had in the lab. And what it turned out to be was that the shelf and the cooler in their test store was 1 inch deeper than it was in the lab. And so as a result of that, the camera, it wasn't really capturing the product. So these are things where, once your model sort of drifts off and it's not performing the way it is, you want to make sure you have that quick insight into that, and the ability then to quickly take a trained model that is performing better and deploy it without that performance downtime as well. And so we have carved out some time here at the end. If there's any Q&A, anybody got any questions, more than happy to answer them. I know that this is how we look at it. There's the different ways in which folks approach these challenges, and look at how do I make sure that my models are performing the way they're supposed to, regardless of the environment. And so, yeah, if you have any questions, let us know. We'll have a couple of minutes here to help answer those. But we also have a number of resources as well, so that what Steve's went through and what you've seen today, you can actually try for yourself. Whether it be you're in an environment where you're working on this as a project within your current work, or if you're looking to reskill and pick up some of those AI and ML skill sets. We have a free community edition. That license doesn't expire. You can have it up and running in a matter of minutes, and you can run through the tutorials. My colleague who's on our Q&A help here, he's our technical writer, and he does a great job of helping create these awesome tutorials and workshops that we have up on docs.wallaroo.ai. And so you can go through the community edition that Anna's posted in the chat, as well as a tutorial that Steve has gone through today as well. And we also have workshops. So tutorials are great. You can then sort of step through the tutorial if you want. But we also have workshops where we've taken some of that code out, and you can actually learn, okay, pop in the code yourself and then run it. And it's a great hands-on way of learning also. So yeah, if you want to go through that route, you can take that as well. And yes, John says so many docs as well. But the great thing is he's organized them super well. And so your ability to not be overwhelmed when you go to our docs website, you can actually sort of find what you need pretty quickly as well. We also have some free inference servers on the marketplace if you want to try them out. Again, what we really try and do is make sure that when you're setting these things up, you're looking at a matter of minutes, and you're looking at days and weeks, because no one has that time available to them. So yeah, in a matter of minutes, you have access to setting up, up to like 10 different VMs of common AI use cases. And so those use cases span from LLMs, Hugging Face, through to computer vision, and ResNet, and so on. And so we have a number of different use cases, and ones we'll be adding to as well over time. And I would love to hear from you. If you think of a question after the fact, if you want to reach out, if you want to give some feedback on the product or documentation, we'd love to hear from you as well. We know that we think we're on the right track, but it's always great to get that perspective from the community and say, hey, look, you might want to think about this, and this is something that we'd like to see. So please reach out to me. I don't bite. So give me a shout. Love to chat with folks like yourselves. And hopefully we'll get a chance to see you in future Reactor sessions. And just lastly, I just want to thank the Reactor team. So Anna and the whole team at the Microsoft Reactor folks, great job. Thank you very much for hosting us again. And also to my colleague, John. Oh, we've got a question, Steve. So what's the best way of model optimization to use for quantization or pruning?
Yeah, it's a great question. It's going to depend a lot on the application and specific models that you're looking at. Pruning is really good for a lot of kind of the more traditional ML models that I've found, but especially with the rise of a lot of the Gen AI models, the trend that we tend to be seeing is that even quite quantized versions of those models still perform very well. And so, we've seen some interesting comparisons of the smaller kind of Gen AI models to quantized versions of the larger ones that are similar in size, that are just a little bit bigger. And then, kind of comparing that performance. And what we find is that, there is actually still significant uptick in performance relative to the amount of space and the amount of compute power that is required. So that's definitely an active area of work for us. It is definitely an active area of research. But as we trend towards these larger and larger models, quantization is looking quite promising. So it's a great question. Thank you.
Awesome. Thanks, Jimod. Great question again. And like I say, if you have a question that you want to sort of answered, or something we can help you with after this session, please reach out. And he's back again. And for CV models, Steve?
It's a good question. I haven't. So I'd love to chat more about it because it depends a little bit. What we're finding is that actually, with CV and the models there today, they're not so huge typically that a ton of the runtime is actually spent in the model. We find there tends to be more overhead around the actual data transfer of images, especially for the large size images, to capture as much information as you possibly can. And so rather than actually shrinking the model, what we find actually lifts the performance the most is having super efficient data pipelining and data transformation coming from that. And not to give a shameless plug, but Wallaroo has a very efficient data architecture there. And that's one area where we've seen folks actually have a lot of luck running CV models at very high fidelity on just a couple of CPUs by taking advantage of a really kind of skinny data processing pipeline. So would love to chat more about that offline, but yeah, that's kind of what we find there.
Awesome. Yeah, Jimod, if you want to reach out to me, you can drop me an email, and I can connect you with Steve, and we can help carry that conversation forward. And yeah, thank you, Steve. Great again to have you here. Thanks to the Reactor team, thanks to John, but also thanks to you for spending your time with us today. Again, like I said, your time is valuable, and we hope this was a valuable session for you, and really appreciate you spending the time with us today. Thank you, and I hope to see you soon. Take care. Bye-bye.
Thank you very much, everybody.